Hello friends, welcome to this lecture of information theory. In this lecture, I will discuss on the topic of entropy. So what is the significance of entropy in information theory? Let us understand that. Entropy is basically denoted by Hx. So an entropy is defined as the average information obtained per source symbol. So this is an important definition of entropy and the relation we can understand it further through a very important relation, and the relation is basically this is a one relation, and we can also write it as this is an important relation that we have. So here what we have to consider that X is basically a set of random variables, and remember this entire theory of entropy was given by none other than Claude E Shannon himself. So since we consider Claude E Shannon as the father of information theory, he was responsible behind the work of the entropy. So we should be very thankful to him, because entropy lays a very important foundation of information theory. So it is a very important concept. Let's discuss what kind of the problems basically asked from this concept. Suppose this is a situation that we have a case where there is a certainty of occurrence of some event. There is a situation of occurrence of certain event with some set of probabilities, that is 1 by 2, 1 by 4 and 1 by 8. Then how we can solve this question using the entropy formula? Using the entropy relation, we can simply have the relation where we have the probability of occurrence of first event how first let us understand how can I, suppose if I consider as a E1, this is basically considered as a x1, x2, x3. So how I can derive this relation with respect to this particular question, that this is px1 log of px1, then summation, we have the summation, then once again we have px2 log 2 px2, then again the summation of px3 log 2 px3. So you can understand that basically it is a sum of the probability, the sum of the product of probability and the logarithm of the probability of which a particular event occurs. So I can reduce this thing as very important relation. So now I can substitute the given values. So px1 we have 1 by 2 log 2 1 by 2, then we have 1 by 4 log 2 1 by 4, then we have 1 by 8 log 2 1 by 8. So how I can solve this solution, that I can have this minus sign and I can put the minus sign here, and in order to obtain the relation something like this, then I can have this thing obtained in this way, and fine. I think you can recognize it what we have done. Then I have simply taken out, I have simply put the minus sign here in order to write this thing in this way. Fine. It is a known fact that when we simply take this thing in the numerator position, the sign of the logarithm ultimately changes. Fine. It is very important. So what we can do now? Now we are in position to solve this. So as I told you in my last lecture that we basically try to solve this thing in terms of the powers of 2. So how I can solve it in the powers of the 2? Basically log 2 raised to the power 1. Similarly log 2 raised to the power 2 in order to obtain this 4, and 1 by 8 log 2 raised to the power 3. Fine. I think maybe it may not be visible for you, so I try to write in a larger font. So I just want to rub these two sections. Fine. So if you are noting this thing, please note it fine as quickly as possible so that I can rub these two portions. Fine. So now I want to write this thing in a larger font. So how this thing would possible? So it would be 1 by 2 log, would be log 2 by 2 1 minus 1 by 4 log 2 raised to the power 2, and then 1 by 8 log 2 raised to the power 3. So now we can simply see that 2 raised to power 1 basically simply becomes equivalent to 2 raised to power 2. It simply becomes equal to the 2 raised to power 4. It simply becomes equal to the 2 raised to power 8. Fine. And we understand that this entire entity becomes 1. So we have the relation obtained as 1 by 2, 2 by 4 and 3 by 8. Fine. So if I take minus as a common here, the entire entity becomes positive, and we can simply have the relation something like this. So I can find out, I can calculate this thing. So what would be the result? It would be 8 and it would be 4 and 3. Fine. 2, 4. So the result would be 11 by 8, and please note down the unit of this. The unit would be bits per symbol. Very, very important. Why bits per symbol? Because we basically consider, as per the definition what I have told you so far, that an entropy is basically defined as the average information. We have the average information that we are obtaining as per source symbol. So this is basically for the source symbol. So this is very important relation. Fine. This is a question. This is how basically the question is solved on the basis of entropy. Fine. Do remember that. One more thing that I want to discuss here, that from this relation what I can do, that I can have this relation also. Fine. And when we have this relation, I can simply replace this entire thing with IXI. That means information. This entire thing basically is related to the information. Very important thing it is. Fine. This is IXI. So this is another very important relation that you have to remember. Fine.